Hi, in this video, I want to introduce you a little bit to configuring a router. So here we have a router, and what a router does is it connects multiple networks. And later we'll learn how a router forwards packets from one network to another network. But for right now, I want you to notice a couple of things. First of all, I'm going to see how the router is really wearing two hats here. It belongs to two different networks in this scenario. In this over here, we have a network which is the 192. Let me see if I can write this okay. 192.168.1.0 network. Okay, there we go. /24. That subnet mask prefix length is very important. Over here, it belongs to another network, the 10.0.0.0/16 network. Okay, over here, the network portion of this address is the first three octets, 192.168.1. Over here, it's the first two numbers, 10.0. This is indicated by the prefix length or the subnet mask. The first 24 bits here is the network portion. The first 16 bits here is the network portion. What I want you to notice is that all the devices over here have that same first three numbers in common. So all these PCs have the first three numbers in their IPv4 addresses, 192.168.1. And our router is going to have the same thing. And its interface on this network, it's going to first three numbers and its, whoops, there we go, of its IPv4 address is also going to begin with 192.168.1. They all have the same exact subnet mask /24, including our router. They do have different host portions of their address. Here we have .50, .103, .102, .101, .100, and our router will be .1. Now, the interesting thing about the router's IPv4 address that you might have noticed is that's the IP address that all these other devices are going to be using as their default gateway. And we talk about this in my IPv4 classes, in the ARP, etc. Okay, so that's their default gateway. Over here on this other side, okay, we actually just have two devices, the router and a server over here, but their first two numbers are 10.0. Okay, that 0 here is actually part of the network, 10.0. Okay, they both have the same subnet mask or prefix length /16. The last two digits of their IPv4 address is the host portion. So we have 01 there, 099 there. And again, our server, which is the only device on this network, its default gateway address is that of our router on this interface over on this side. Okay. So what we're going to do in this lab here is something very simple. We're just going to configure the router using Cisco IOS. Okay. So let's go ahead and get started. Okay. All right, so I'm just going to bring up the router, and we're going to just start from scratch here with configuring all that good stuff here. So let me hit enter, enable. Okay, config T, go into global configuration mode. First thing I'll give it a host name. I'll say host name, and we'll just call it edge router, giving it some kind of name there. There we go. Just give it a host name. One of the first commands I always like to do is no IP domain lookup. I cover all these commands in other videos and in my class. Okay, that keeps, if I make a typo, keeps the iOS operating system from going out thinking that I'm giving it a name of a device I want to remotely connect to and starts looking for a DNS server. Anyway, let's give it a enable secret privilege exec password. We'll give it class. And let's go into line console 0, give it a password. So let's say login. Let's see, password first, password Cisco, login prompt. Also to keep our session from timing out. Now, this is something you only want to do in a lab environment, and that's exec timeout 00. That's just to keep the router from timing me out if I'm not typing in commands here. But again, only in a lab environment because we want it to in production. If I walk away, get a phone call or something, or need to go talk to somebody and I forgot to log out of my devices, I want to log me out after a certain amount of time. We're also logging synchronous. I'm going to use my helpful tab key to auto complete. That's so when I'm typing in a command, if there's output from iOS, it doesn't interrupt what I am doing. Okay, let's also configure this for Telnet. And how many sessions can I have? I can have up to 16, 0 to 15. Now, normally you're not going to have 16 people remotely accessing your device. But we're going to configure this just for Telnet. Let's do transport input. And if you see, I have some options here. SSH is the preferred. That's what we'd use in a production environment. But because the video that this class is for, we haven't gotten there yet, we're using Telnet. Telnet does not encrypt the password or the data between the client and the Telnet server, in this case, the router. So SSH is much more secure. Let's give it a password Cisco login. So that allows us to Telnet into the router. We'll give that a try at the end here. What else do we need to do? How about a banner message of the day? Those are always kind of fun. I use a $sign as my delimiter, and we'll just put in a bunch of hashtags here. Okay, make this authorized access only. Get some more hashtags. When I'm all done, use my $sign to add, that's my delimiter that I chose up here. There we go. All right, there's my message of the day. I think now what we are ready to do is configure the interfaces. Notice I have two interfaces, gig 000 and gig 001. So let's do this. Interface gigabit 000. I'm going to say IP. IP means IPv4, by the way. Later we'll do IPv6. IP address 192.168.1.1. And we have to give it a dotted decimal subnet mask. iOS still does not support on most of its platforms a prefix length. So I got to do 255. I can't do /24. I have to do 255.255.255.0. And that's it, except one more thing. I got to do a no shutdown, and watch what happens when I do a no shutdown. Right now, this interface is in shutdown mode. It's disabled. Okay, when I do no shutdown, what's going to happen is it's going to turn on the interface. We'll get an iOS message. There we go. Immediately goes to green. The switch, our Ethernet switch, its light right now is amber for about 50 seconds. As Spanning Tree does its thing, make sure there's no loops in the network. And then this link light on the switch will be green, and it will start forwarding frames out that port. Okay, let's do this now. I'll do an exit. Interface gigabit 0, get that out of the way. Over on the other side. Now we're going to do this one over here. IP address 10.0.0.1 255.255.0.0. Again, no shutdown. Okay. I'm going to do a end here. You can again see that this got a message from iOS that the interface is now up. Again, this light is amber on the switch will go green, just like this one over here did. Okay, let's do an end. All right, a few things here to take a look at, just verifying what we've done. Let's do a show running config. And I'm doing autocomplete here. And what we'll see, there is all these commands that we've put in that we should be familiar with a little bit by now. But there is my interfaces configurations. Okay. Now you won't see no shutdown. By default, it's shutdown. That's the default. So no shutdown actually removes that. So that's why we don't see no shutdown. Okay. If I did show startup config, you notice that there's nothing in the startup config because we don't have anything there yet. So I'm going to do copy running config to startup config. I'm just using the autocomplete, the tab key, just to show you the entire command. Now, if I do, I'll hit the up arrow to show startup config, there it is. So if the router reboots, I have my configuration. Okay, one of my favorite commands is I show IP interface brief. Okay, let me make this a little longer here so we can see the whole thing. This shows us our two interfaces in a brief format, and shows the IPv4 address of each, tells us that they both are up. We want to see this up and up. That's what we want to see. Okay. And we configured them manually. So that's a great command. Some other commands we can use too. Show us a little bit more information. Show interface gigabit 000, for example. What this command here does is it shows you, let me make that a little, whoops. Make that a little long. Well, I'm having trouble here early in the morning. There we go. All right. What this shows is basic interface information. It does show your IPv4 address. It also shows the MAC address on that interface. Some other information it shows you is just interface information about packets coming in and out. Okay, we'll take a look at some of this more detail later. We can see the port is running full duplex, 100 megabit. That's a gigabit port, excuse me, 1,000 megabits per second. It did auto negotiation with the switch. Okay, another similar one to this is, I'm going to cheat here. Instead of show interface, I'm going to do show IP interface gigabit 000. The main difference between this one is it shows mostly information pertinent to IP. So we can see the IP address, the broadcast address, and then there's a bunch of other information. I'm not going to go through all this now. We talk about some of this later. Some of it is just everything but the kitchen sink. It shows you in case you need to know. A very, very important command we want to take a look at here is show IP route, a routing table. Okay, so by configuring two different IP addresses on this router that belongs to two different networks, and by the way, when you configure an IP address on an interface, it belongs to a network. A router cannot have two interfaces that belong to the same IPv4 network. In other words, I could not have configured gigabit 001 as with the IP address 192.168.1.2/24. That would overlap with gigabit 000, and iOS would give me a message as such. Okay, so when I configure an interface with an IPv4 address, just like your host, okay, we'll take a look at that in a moment, but it belongs to a network. This router says on my gigabit 000 interface, I am directly connected. That's what the C is. I am directly connected to the 192.168.1.0/24 network. That means I can reach any devices. I can reach any devices that begin with 192.168.1.0 directly. I don't have to go through another router. Okay. And we talk about this with ARP and things like that. On the other side, I belong to the 10.0.0.0/16 network. I can reach any devices that belong to the 10.0 network, 10.0 anything over here without going through another router. Now, something that might look a little confusing is it shows you these addresses down here. This is known as its local address, not link local, but local. We talk about link local later. A local address means this is the local address on this router. Now, its mask is not /32. Its mask is a /24. Why does it show /32? We'll talk more about this when we get into some of my other classes and we talk about routing, but basically what this means is a packet gets a packet for itself, like we are trying to telnet into the router or ping the router from a client device at this address. If 32 bits match the destination IPv4 address of the packet with this address here, then the router knows, oh, this is a packet for me, not a packet I need to forward to another router. If that doesn't make sense to you, don't worry about it right now. Okay. Let's take a look at something else here. Let's go over to one of these PCs. Let me go PC 0, I think. We'll use that one here. Desktop, command prompt, ipconfig, right? Okay, we can see it is also a member of the same network, just like the router. They can reach each other directly. They can encapsulate packets to each other directly in an Ethernet frame with the other one's destination MAC address. Can I ping my router 192.168.1.1? Yes. Okay. Matter of fact, if I do show, if I do ARP-A, there's my ARP table. It says I've got using an ARP request, PC 0, received an ARP reply from the router and got the router's MAC address. Matter of fact, we saw that over here, right? The MAC address on the router. Let's see if I can do this here. Let's scroll up here. Here's that MAC address on the router, 3301 on that interface. And if we come over here, we can see it was, I click on the wrong one, 3301. Well, it's the whole thing. It just ends in that. Okay. All right. So let me make sure that's a little bit more clear for you here. There you go. You can see them both together. Okay. There's the MAC address on that interface. All right. What else did I want to show you here? We can ping. Can we ping the PC over here? Well, we actually can in this case. Let's try 10.0.0.5. Okay. Now, don't panic if we get a couple of request timeouts. That's just the ARP process doing its thing. Oh, I pinged the wrong address, didn't I? I was trying to ping a switch and this address does not exist. Okay, in that case, we're not going to work. There we go. Let's do 99. That's the address. That's the address of the server. I have not configured the switches, an IP address on the switch. There we go. All right. Yes, you can configure IP addresses on Ethernet switches. We talked about that previously, just to be able to remotely access it, but I have not done so in this case. All right, so we can ping. Now, the reason why we can ping this device here on another network while that's successful is, again, the router. Let's look at its routing table. The router belongs to two networks, so it's able to forward packets from one network to the other. So I belong to both of these networks. Okay, one last thing I would like to do is show you that we can telnet into this router, because we configure telnet 192.168.1.1. There we go. Cisco. There we go. I'm on that router. I'm sitting at my desk in my office and I'm able to access the router. I just want to make Be careful I don't do anything that disables my connectivity. Like what? Well, let's do it. It's always fun to mess up. Class, all right. Let's do this. Show IP interface brief. Okay. Oh, yeah. Okay, I see. See all that good stuff. Config T. What if I did this? Interface gigabit 000. So I'm on this interface here, the one that I'm connected to. What if I did a shutdown? What would happen? Okay, let's do it. I just did it. Notice I'm hitting enter here. Did you see the link light here go off? I just disabled my access and really access for the entire network. So what do I have to do? I got to walk, drive, whatever, get over here to where physically where the router is, console in, and console in. Matter of fact, I can see on my screen, if I had a computer connected at the time, that I received a message that this interface has been changed to administratively down. Matter of fact, let's do it. Show IP interface brief. And you can see it says administratively down. We don't want that in this case. Config T, interface gigabit 000. Let's bring that puppy back up. No shutdown. There we go. Comes back up. And we're good to go. Now this light here is going to be amber. Matter of fact, if I try to do a ping right now, let's see if I can ping the switch here, 192.168.1.1. Okay, I'm going to get a request timeout until that link light on this switch goes green. Okay. We talk about in later classes, we talk more about spanning tree and how in some cases like this here, we may want that link light to go green immediately. Okay. There we go. Now it's working fine. All right. So I hope this helped explain a little bit about configuring the router having two IPv4 addresses in this case, one for each network. Now we have reachability from devices on this network to devices on this network. Hope you enjoyed this video. Thanks.